Okay, so here we go with part 2. Let's get this up and running. Okay, so now we're going to look at what happens when I take an exponent and I raise it to another exponent. So if I look at this expression here, I'm taking a squared and then raising that exponent to the 4th power. Okay, so what does that mean? Well, that means I'm taking a squared and I'm multiplying it by itself 4 times. Okay, but then we can break that down further, because this a squared is a times a, this one's a times a, and each of these are a times a. So grand total, I've got 2, 4, 6, 8 a's here. So this should equal a to the 8th. Okay, so if we go back for a second, we see, well, what happened? I had a squared, and I raised it to the 4th power, and I got a to the 8th. Again, the important part to notice here is if we look at our exponents, I'm raising an exponent to another exponent, and what do I do? Well, I multiply. 2 times 4 equals 8. So last time we said that multiplying 2 exponents turn into addition. Well, here, raising an exponent to another exponent turned into multiplication. Okay, so if I were to write this to as an algebra notation here, I've got x to the a raised to the b. Well, I'm going to multiply those, so that is the same as x to the ab. So I'm taking my 2 exponents and I'm multiplying them. And so just for an example, if I've got x cubed to the 3rd, well, I'm going to multiply my 2 exponents here, so that would be x to the 9th. Okay. So now again, let's look at some examples. Again, exponent to an exponent turning into multiplication. Well, here my base is 5, and I've got 2 to the 3rd, so 2 times 3 is 6. So that's 5 to the 6th power. Okay. Here, same thing. I've got my base is v. Now I'm taking 7 and I'm raising it to the 4th power, so I'm going to multiply. 7 times 4 is 28. Okay. Here my base is -2, so we want to leave that in parentheses. And that's raised to the 5th and then to the 3rd power. 5 times 3 is 15. Okay. Here, there's a couple things going on. Don't let the fact that our base looks a little weird cause you any panic. Okay, my base is z minus 4, so I'm going to leave that in parentheses. And then my exponents, I'm raising it to the 3rd power, and then again to the 4th power. So I just multiply. 3 times 4 is 12. Okay? So, and I've got an exponent raised to an exponent. I think you guys can handle this just fine. Just go ahead and multiply. We're not going to have any issues. Okay? I think the last property we're going to look at today says, well, what happens when I've got 2 things being multiplied raised to an exponent? Okay, we're going to call this our power of a product property. Well, let's check this one out. I've got ab to the 4th. So what happens? Well, I'm multiplying ab by itself 4 times. Now we know I can multiply things in any order, right? If I have, say, 2 times 3 times 4, that's the same as 4 times 2 times 3. Right? I can change the order these are multiplied. So I'm going to change the order so that all the a's are together. So now I've got a times a times a times a, and then put all my b's together. 2, 3, and I got 4 of those. Okay. So what happened? Well, now I've got a to the 4th and b to the 4th. So again, so if I just go back to what I started with here, I had ab to the 4th. We said this is a to the 4th, b to the 4th. So we took our exponent and we distributed that to both pieces. So I took my 4th power, kind of like when we distributed using multiplication. Now I'm just distributing an exponent. Okay, but we're going to apply that exponent to every piece on the inside there. And that's going to be important going forward. Okay, so just using the algebra notation, if I've got AB to the n, okay, again, apply that exponent to everything on the inside. So I'm going to do A to the n, and then I'm going to do B to the n. Okay. So maybe I've got, let's say, x, y, so let's do cube this one. Okay, well, I'm going to apply that cube to each piece. So I'm going to do x cubed, and I'm going to do y cubed as an example. All right, and then we've got just a couple examples on the bottom here. For part A, there's two different ways we could do this. Okay, we could do, well, order of operations says do parentheses first. So we could do 4 times 9 is 36, and then raise that to the 7th power. Or we could use our new property. And our new property says raise our exponent to each piece separately. So I could say that's 4 to the 7th times 9 to the 7th, and then I could multiply. Okay, either one of those would give you the exact same answer. Okay, so for today, we're going to focus on using our property. So I will get rid of this part. But know that that's also something you could do if you wanted. Okay. Let's go back here. Now for our next one. Now I've got x squared to the 5th. So let's break this up. So I'm going to apply my exponent to each piece. So I've got x squared to the 5th, and then y to the 5th. But then we can use our exponent raised to an exponent property. X squared to the 5th means I multiply. So that's like x to the 10th, y to the 5th. Okay. Next one, I've got negative 3rs squared. So again, I'm going to take everything in there, I'm going to apply the squared to it. So I've got negative 3 squared, and then r squared, and s squared. And just to finish it up, we can do this. Negative 3 times negative 3 is positive 9. R squared, s squared. Okay. So be careful with the negative. Don't let that trip you up. Remember, a negative times a negative is always a positive. Now the difference with D here, notice where the negative sign is. The negative is outside of the parentheses. Okay. So pretend this is like a negative 1 that's hiding on the outside. Okay. Well, now I've got this negative 1 here. And then I apply the square to everything in the parentheses. So now I'm going to do 3 squared, r squared, s squared. So this time, well, 3 squared is 9, but then 9 times negative 1 is negative 9. Okay, so notice the difference between these two. In C, the negative was on the inside, so we multiplied negative 3 by negative 3, and it became positive. But for D, the negative's on the outside, so we multiply that at the end. Okay, so that's why that one's negative. Let's circle our final answers here. Okay, so notice the difference between C and D. Okay, we're going to have one more short video, do just a couple more examples where we put all this together, and then again, you guys are going to work on Delta Math.